Good morning, welcome to
Math Problems number 129.
Math Problems number 129. So we started a new section in our book today, and it was about inequalities.
Yeah.
Okay? And inequalities are neat. You're used to seeing equations that say things like x equals 7.
Yeah.
And when x equals 7, what do we know about x?
X is 7.
It is 7. And so today we started talking about a slightly different equation called an inequality, or I might write it like this. And what does this say?
It says x is less than 7.
X is less than 7. In this one, we knew what x was. X was equal to 7.
Yeah.
Do we know what x is here?
No.
What could it be?
It could be anything less than 7.
Okay, for example?
6, 5, 4, even some fractions like 6.5.
Yeah.
6 1/3, 6 1/4.
Yeah, it could be any of those. What could it not be?
Couldn't be 8.
Could not be 8. Definitely not 8.
No.
No. Okay, and so in talking about inequalities, some interesting statements about numbers come up. So the first thing I want to tell you that for any two numbers, x and y, either x is greater than y,
Yep.
x is less than y, oops, x is less than y, and what's the third possibility? Either x is bigger than y, or x is less than y,
Or x is equal to y.
Or x is equal to y. That's it. Those are the only choices. Now that seems pretty obvious, right?
Yeah.
But that turns out to be a pretty important thing to remember.
Yeah.
For two numbers, either one, x is bigger than y, x is less than y, or they're equal to y.
Yeah.
So we always have to keep that in mind. And there was a nice example in the book with three numbers. If x is bigger than y, y is bigger than z, what can we say about x and z?
X and z, x is bigger than z.
Why is that?
Because x is bigger than what is bigger than z.
X is bigger than what is bigger than z. Very good. So in this case, if we have three numbers and we know x is bigger than y, so we get smaller going to y.
And then we get even smaller going to z.
We get even smaller going to z. We know that x is bigger than z. We have to get smaller to go from x to z.
Yeah.
But in a different situation, if x is bigger than y and y is less than z, what can we say about x and z?
It varies. If you put numbers in, it's gonna vary if they're bigger or not.
Okay, so give me an example where x would be bigger than z here.
Well, 11 could be bigger than 4.
11 is bigger than 4.
Or
And, okay.
5 could be bigger than 10. 5 could be less than 10.
Well, no. Oh, sorry. I didn't explain correctly. So in 11, if 11 is bigger than 4, 11 is x, 4 is y.
Yeah.
What we're trying to find out what's z. I want x to be bigger than z. So can you give me an equation that 4 is less than something?
4 is less than 7.
7. Okay. And so here we would know that 11 is bigger than 7, right?
Yeah.
Now give me one where x is less than z.
X is less.
So 11 is bigger than 4. Now make z bigger than 11 and make this equation be true.
13.
13. There you go. So now we would know that 11 is less than 13. So we can't say anything about this.
No.
Could x and z be equal?
Yes, they could.
How would they be equal? What's an example where they're equal?
5 could be equal to 5.
Well, in your example here, what would z have to be equal to x?
It'd have to be 4 in this example. If z were to be equal
To x.
to x,
What is x?
x is, in this example, it's 11.
X is 11.
Then you have to raise it to 11.
What? Raise what to 11?
You have to raise this z to 11.
Which is z on the board right now? Can you point to it? in this line here, what is z?
In that line there, z is
13. Very good. Okay. So if we make this equal to 11, 11 is greater than 4. 4 is less than 11. That says 11 equals 11.
Yeah.
Okay, just like we said, it could be greater than, less than, or equal to. So in this example, if we know x is greater than y and y is less than z, we don't know any relationship between x and z.
No.
X could be greater than z. We did an example like that. X could be less than z.
Or x could be equal to z.
Or x could be equal to z. It's pretty confusing, right?
Yeah.
So you have to really pay attention on inequalities. That was a good first day on inequalities, right?
Yeah.
All right. Good job, sweetie pie. Good job.